Okay, hello Charlie. This has been the tutor talking about integrals. So we were discussing this integral. And I want to show you how to do it. So when we begin any integral, we have to ask the question, what method do we use? All integrals are done by methods, at least all difficult ones. And we think about something like substitution, and substitution is not going to work. If we tried x squared minus 9, we wouldn't get rid of this x squared. So that won't work. If we tried by parts, we could think about x squared and root x squared minus 9, but this thing isn't going to go very well by parts, so that wouldn't work as well as either. Partial fractions won't work. So the method that works for this is trigonometric substitutions. In particular, this one. So I notice that x squared minus 9 is inside the square root. And if I could substitute that for something, and to simplify the square root, that would be nice. And this this identity is of the form something squared minus 1, or a number. So if I can choose a substitution carefully, then this can be helped and made a lot more simple. And my substitution is u equals secant x. Now I don't do secant x squared because I want to replace, oh my goodness, sorry, we did this last time. X equals secant u. That's what I want. So I don't do secant x squared because in here x is already squared. And I want to make it so that it fits this thing here. So I write x is secant u. But actually not just secant u, it's 3 secant u. And that's to match this 9 here. Because when I square this, it'll be 9 secant squared u, and I can factor out a 9, and then I'll have this identity that I can use that. So now I do the substitution. Wherever I see x, I plug in this, but I have a dx here, so I actually need to also take this dx du, and that is 3 10 u secant u. So we got the dx here, and we move du over here from here, so we write 3 10 u sec u du, and that'll be the substitution for dx. Now notice, I'm not writing u equals something, I'm writing x equals something, so this is different than other substitutions we've done before. Okay, so let's go. I see dx, I write 3 10 u secant u du divided by x squared is 3 secant u squared, and a big old square root, 3 secant u squared minus 1, sorry, minus 9. So I'm going to get 3, and I'm going to get 9 there, so I'm going to get all this over 3. The secant is squared, and that's going to cancel with that one, so we get 10 u du secant u on the there, and the square root, I have 9 secant squared u minus 9. Now I factor 9 out of this guy, and that'll be like a root 9, so that'll become 3. So this is 3 times 3, so 9. 10 u du secant u times square root secant squared u minus 1. So I factored the 9 out of this, that one and that one, and brought it out of the square root, and it became a 3. Now this is just tan squared. Secant squared u minus 1 is tan squared. So tan u du over 9 secant u times square root tan squared u. And here's the lovely magic step. This is tan squared square root, that's tan, so it cancels with that one. So I get the 9 can come out as a fraction, integral du over secant u, and that is cosine u du. And we can compute that easily. That's 1 over 9 sine u plus c. Now, we finished the integral, but sadly, we started with x's, and we have a u in the answer, so we have to do a substitution back. And that's going to be a little bit tricky, but not too hard. Okay. So, we have 1 over 9 sine u plus c. And we also have, remember what our substitution was, x equals secant u and 3 secant u. Okay, so I'm going to use another trigonometric identity. This one is very commonly used. Sine squared u plus cosine squared u equals to 1. Now, what does this mean? If I can get this secant in some kind of form like this, really I'm going to use this one, sine squared u equals to 1 minus cosine squared u. Something like this. Actually, no, the other way. It's cosine squared u equals 1 minus sine squared u. I can transfer this guy into something like this guy, then I'll be able to write it in terms of sine u instead. That is to say, if I can figure what sine u is in terms of this equation, then I can do the substitution. So I write 3x. What is secant? It's a cosine over cosine u. Now I'm just going to swap it around because it's easier to think about this way. Now in this identity, I have cosine squared u, so I'm just going to square both sides here. So cosine squared u equals 9 over x squared. Square both sides. And there we go. 1 minus, that's the identity, sine u, for 9x squared. Now I move things around. 1 minus 9 over x squared equals sine squared u. And I take a square root of both sides because I want to find what is sine u. And I get this. Sine u equals square root 1 minus 9 over x squared. So I got it from here and using a trigonometric identity. Now I look back here and I say, hey, that's exactly what I wanted. So I substitute this x term back there. So that is the final answer of the integral. There it is. I hope that makes sense, Charlie.